This is a nice graphic, and it looks at the differences between MSG2 and MSG3. And if we look at MSG2, first of all, remembering that this was the first system that was widespread. In fact, MSG1 appeared for a very short period of time, less than 1 year, was applicable only to one aeroplane, the 747-100. MSG2 was applicable for all subsequent aeroplanes. We talk about a bottom-up approach. What does that mean? It means when we consider the maintenance, we start with the system and we look at all the components within that system. If it was the fuel system, we start with the sensors, the switches, the valves, the pumps, and so on and so on and so on, and work our way up to the flight deck. Whereas MSG3, they turn the whole thing around and they look at the system integrity. So the checks that we look at in MSG3, more checks are from the control point of view of the system. Is the system operating correctly? Can we test the system? Can we test it from the flight deck environment, for example? So MSG2 process orientated, MSG3 task orientated. And during the MSG2 we have two types of activity. We have an activity which we call hard time. Hard time is a life that we give to a component. On condition means we leave the component on the aircraft until there is a failure. But during this process, we are in actual fact performing tests, inspections to understand the integrity of the component has not been compromised. There is one further term. Condition monitored. And condition monitored is a little bit misunderstood, but basically condition monitored means that we just pay attention to the component. We don't do any work on it, we don't do any inspections, we don't do any checks other than the general inspections that we do of the aircraft integrity. And condition monitored, we wait until the component fails. So obviously some components can't be condition monitored. Engines could not be condition monitored because we can't wait for the engine to fail. They can be on condition, and as we said before, if an engine is on condition, we will be doing inspections of the engine data. We will be doing inspections of the condition of the engine internally using a borescope. We will be doing inspection of the oil within the engine using analysis in the laboratory. We will also be looking at the evidences from the magnet in the bottom of the oil tank, the magnetic chip detector. This is on condition. Condition monitored might be a pack valve, air conditioning pack valve. If it fails, it's okay because we've got multiple air conditioning components and a single pack valve failure won't cause us any problems. So we will leave it as a condition monitored item. And as we say, MSG process, we live with it for 10 years. We replaced it with the MSG3 process. We still have hard time. What does hard time mean? It means the component has a life limit. However, if you look at the number of components on an MSG2 aeroplane compared to the number of components on an MSG3 aeroplane, which are hard time, very, very few components are hard time on MSG3. Why? Because we leave the components on the aircraft typically as on-condition components. Components that will be hard time are components that have to work very hard. For example, the landing gear. Every time the aircraft's landing, it's taking a huge load on the landing gear. So these guys are hard time components. Maybe some flight control components, hard time components. The flap system components, hard time. Around the rest of the aircraft, very, very few. MSG2, quite a few. On condition, we also have on condition for MSG3. Same. In fact, these guys are almost identical. However, there is no condition monitor program for MSG3. It was replaced with a zonal inspection program. And the zonal inspection program is the program that includes, we were talking about the structural sampling, and we were talking about the corrosion protection. So all of these guys are embedded in the zonal inspection program. The zonal inspection program is one of the key factors of the effectiveness and the integrity of the the entire MSG3 process. It's also one of the weaknesses, because if it's not done correctly, then the aircraft suffers. The reliability of the aircraft maintenance suffers if the zonal inspection program is not done correctly. And again, as with all the other areas that we talk about, competence is a key point. In the aftermath, we had two very serious accidents. We had an accident in 1996. In July 1996, TWA 800 took off from Kennedy Airport, and it was climbing over Long Island, and at 14,500 feet, the center fuel tank exploded. Yeah. The nose of the airplane plunged into the sea, Long Island Sound, and the rest of the airplane carried on climbing for 3,000 feet. It stalled and it came down into the sea. 238 people lost their lives. In September 1998, an MD-11 belonging to Swiss Air took off also from New York. It was coming over to Europe. And within 15 minutes, 20 minutes of takeoff, there was the smell of smoke on the flight deck. 26 minutes later, the airplane plunged into the sea, and they reckoned it was doing in excess of 100 Gs. It came down like a bullet. It hit the water, and it broke up into pieces which were millimeters. And again, huge loss of life. And behind this is the need for effective inspection. And there was a huge investigation process that went on following this. As an example, there was an exercise done with the Aviation Transport Rulemaking Advisory Committee, a group of guys called AXRAC. And these guys were doing inspections on a fleet of aeroplanes when the maintenance check was finished. So the maintenance check is complete. They took the aeroplane and they put it in another hangar, and then this group of guys had a look. And they didn't do it for one aeroplane. They did it for 80 aeroplanes. And at the end of it, when they got their data together, on 80 aeroplanes that were released to service, these aeroplanes good to go, signed, ready for passengers, they found 3,300 defects. And what they started to understand is that the inspection product is weak. And they made recommendations that organisations should do inspection training. It was a recommendation. And unless it's embodied, then organisations choose maybe not to do it. And here is one of the fundamentals that we're left with. Do you do something because you have to do it, or because you want to do it? So the reality is today that the inspection process is the weakest part of the maintenance process. EASA and the FAA have failed to embody in an appropriate way the recommendations of the National Transportation Safety Board, because they do not mandate inspection training. It should be mandated. Instead, what they've done is they've said that the organisation should demonstrate and manage its competence, which includes inspection training, rather than making it in detail. And so now we're back to relying on the integrity of the regulators to understand what I've just explained to you. Because if an organisation is not managing the competence of its inspection process, how is it managing the effectiveness of its maintenance product? We have lots of challenges in our aviation, and it's absolutely incorrect to believe that the regulatory authorities, which are driven by EASA, the FAA, and so on and so on, that they have got all the answers. Not correct. There is an industry that has to manage itself in the most appropriate way. And sometimes decisions have to be made for correct reasons. Okay, so we've got here the tasks we spoke about here, hard time. It says OV here, it's on condition and condition monitored. And here when we're talking about processes, we've got a whole range of processes here which come down to on condition, zonal inspection, hard time, and some of these on condition processes include lubrication, they include servicing, they include operational checks, they include function checks, restoration. We're going to go through all this in detail.